Hi everyone. Welcome. In this session, we will learn the definition of electric charge, voltage, and current. Also we will learn about alternating current and direct current. At the end, questions and answers session will be there.
If you rub a rubber on a paper, the rubber will attract a corner of the paper. The paper and rubber give the evidence of static electric charge. The work of rubbing resulted in separating electrons and protons to produce a charge of excess electrons on the surface of the rubber and a charge of excess protons on a paper. When an atom loses an electron, it becomes positively charged particle. An atom becomes negatively charged particle when it gains an electron. Opposite charges attract each other and charges of same polarity repel. The unit of electric charge is named after Charles Augustin Coulomb, a French scientist, who measured the force between charge. 1 coulomb of charge is equal to 6.25 times 10 to the power of 18 electrons or protons. The reciprocal of 1 coulomb of charge gives the charge of an electron. Charge of an electron is 0.16 times 10 to the power of minus 18 coulomb. This extremely small charge of an electron was measured by Robert Millikan, an American scientist. Potential refers to the ability of doing work. Any charge has the potential to do the work of moving another charge, by either attraction or repulsion. When a charge is different from the other, there must be a potential difference between them. Potential difference or voltage is the measure of amount of work needed to move an electric charge. When 1 joule of work is required to move 6.25 times 10 to the power of 18 electrons between 2 points, the potential difference between those points is 1 volt. 1 volt equals 1 joule divided by 1 coulomb. The unit of potential difference, the volt, is named after Alessandro Volta. When the potential difference between two charges forces a third charge to move, the charge in motion is called as electric current. When the charge moves at the rate of 6.25 times 10 to the power of 18 electrons flowing past a given point per second, the current is 1 ampere. This is same as 1 coulomb of charge per second. Let's see how current is different from charge. Charge is a quantity of electricity accumulated in a dielectric media. The charge is static electricity without any motion. When charge moves in a conductor, the rate of movement of charge is current. The unit of current, the ampere, is named after André-Marie Ampère, a French physicist. Direct current or DC is the flow of charges in one direction with fixed polarity. DC voltage can change its magnitude with same polarity and direction if current still flows in one direction. An alternating voltage source periodically reverses its polarity and hence alters its direction of charge flow. The 60 Hz AC source means that the voltage polarity and current direction go through 60 cycles of reversal per second. Question number 1. 25 times 10 to the power of 18 electrons are added to a neutral dielectric media. Calculate the charge Q accumulated in the dielectric media. The answer is minus Q equals 4 coulomb. Explanation: 25 times 10 to the power of 18 electrons equal 4 coulomb of charge. Since 1 coulomb of charge equals 6.25 times 10 to the power of 18 electrons, negative sign minus Q indicates negative charge. Question number 2. 0.75 joule of energy is spent in moving 0.5 coulomb of charge between 2 points. Calculate the voltage across those 2 points. The answer is 1.5 volts. Explanation: we know that volt equals joules per coulomb. 0.75 joule divided by 0.5 coulomb gives 1.5 volts. Question number 3. The charge of 1 coulomb flows past a given point every half a second. Calculate the current. The answer is 2 ampere. Explanation: we know that ampere equals coulomb per second. 1 coulomb divided by half a second gives 2 ampere.